Greetings to everyone. We're glad to have you here. This is part of the SNIA NSF Networking Storage Forum. And today we're presenting the webcast topic on storage technologies and practices ripe for refresh. So if you like, there's a way you can zoom up so that this presentation fills your entire screen. I recommend you do that. In places there will be some smallish sort of text, make it a lot easier to view. When we get to the end, please send us your feedback. This is how we can improve our presentations for you. The very last slide in this presentation will have a link to the Q&A section, okay? When we're done, we will have questions. Those that we don't get to live, we'll be able to take care of later. And if you need to drop off for any reason, of course, you can come back to our blog page and get answers to all of those questions. Feel free to ask your questions throughout, and we may be able to answer them immediately. Certainly we will at the end of the presentation, within the time that we have available. So today's speakers, this is Tom Friend, I'm your moderator. In order, it will be Eric Hibbard, who is a longtime security expert for SNIA, then followed by John Kim, who's our chair for the NSF group, and then we finish up with Alex McDonald. So SNIA is the Storage Networking Industry Association. We're a group of 185 different leading organizations within the storage industry. Some are suppliers, some are customers, all are very much deep inside the storage industry. All the major leading players in this organization are here. We have over 2,000 active and contributing members and over 50,000 end users and storage professionals worldwide that are regularly a part of the things that we do. The technologies we cover here in the NSF group include Ethernet, fiber channel, all of the things you see listed here. We're very much about anything where storage and networking are connected together. Yes, the legal notices. I'm not an attorney. I don't play one on TV, but I have been asked to remind you all that the material is copyright by SNIA, unless you see it otherwise noted specifically. You're welcome to use any of this material in presentations given the following conditions as shown on this slide. Now, of course, none of us are attorneys, and none of this is considered to be legal advice. So please consult your attorney if you think it's all necessary, ... So our agenda today. Eric will begin our discussion talking about some security problems. Then John will talk to us about some different network storage protocols that are not quite retired yet, but you may want to start thinking about it. And Alex has a lot of wonderful feedback for us on different NAS protocols and the versions that are right and versions that are too sketchy to use anymore. So with that, Eric Hibbard, please proceed.
Thank you very much. So I love the title for this talk, Ripe for Refresh. It's definitely interesting from a security perspective. Ripe is usually result of something like a black swan event, where there's something has occurred, and as a result, there's a scramble to update, deprecate, as a response. And of course, a lot of this is because we've got active adversaries probing and poking and trying to exploit. So I'm going to touch on many things that you could probably do a half a dozen talks. So this is going to be a bit of a whirlwind tour, but it's to essentially set some foundation for, I think, some of the other topics, because security is going to show up as part of the concern and whatnot. So I'm going to start with cryptography, which is at the heart of an awful lot of the security that we deal with. And in many cases, the cryptography is not perfect. As computers get faster, computational capabilities increase, some of the algorithms become less and less useful from a protection perspective. And we've definitely got instances of that right now, where we've got encryption algorithms that are basically considered broken. The reason we'll call it broken is that an attacker or an adversary can essentially, without knowing your encryption key, almost real time in some cases, be able to decrypt the data that you're encrypting. So if the whole point is confidentiality, then you don't have much protection. It may be measured in minutes. We've got examples of the RC, for example, 4, but predecessors to that, and DES, which if you go back maybe 15 years ago was pretty commonly used. The use of either of those families of ciphers is definitely discouraged, assuming confidentiality is something that you're concerned about. There are also problems with key sizes. So if you have key sizes that are basically less than 128 bits, you're potentially in the danger zone, because the computational capabilities have gotten to the point where less than that is potential exposure. May not be instantaneous, but if a data stream, for example, is captured within maybe a few hours or a few days, an attacker may be able to essentially get at what you've got going on. There's also issues with hashing algorithms. Hashing algorithms are handy tools, and the issue there is whether you've got collision rates. So if you can imagine, you've got two documents that, if you take a hash of the contents, you get basically a fixed size result. If you've got two documents that hash to the same value, that could be a problem. And we call that collisions. And we're finding that, for example, MD5 is already at a point where there are lots and lots of collisions, and you probably want to be careful in terms of using it. In fact, many organizations are banning its use. SHA-1, which has been around for a while, is basically on that same flight path. So we're actually moving on to things like SHA-2 and potentially SHA-3 for secure hashing mechanisms. There are problems also in key negotiations. Another area of problem is around entropy. So do you have enough randomness? So if you're generating, if you've got to achieve 128 bits of security, if in reality, when you look at a crypto system, it only has 8 bits of security, you're in serious trouble, because if an attacker has an awareness of that, they may be able to actually pre-calculate all the keys that you could generate and then try them out near real time, and again, you're in trouble. So cryptography is a really big problem area from a security perspective. If you've not had an opportunity to look at the NIST Special Publication 800-175B, I would encourage you to do that. It does an excellent job of going over lots and lots of the issues. So the next one that warrants some definite review is the SSL and TLS topic. So it's the secure socket layer versus transport layer security. Anybody that basically talks about SSL, well, I have words for you. You should not be using it. You should not be talking about it because it is massively broken and absolutely vulnerable. You have no guarantee of protection of anything when you're using SSL. It's in that bad a shape. In fact, even TLS, prior versions before TLS 1.2 are very suspect. And again, many organizations are not only banning their use, but if you have a product that includes either SSL or TLS prior to 1.2, it may be flagged as a vulnerability if your security team is running security scans against your systems, and grief will result as a result of that. So in addition to the protocols, which is what these versions are about, there are things called Cipher Suites, and Cipher Suites are the way to sort of identify what kind of cryptographic mechanisms are going to be used when you use, for example, TLS. And it turns out that there are combinations that include some of the weak crypto that I was just mentioning, and you in fact don't want to use those. And this is another area where you may be using the right version of TLS, for example, TLS 1.2, but you have allowed the use of maybe RC4 for encryption. And again, a lot of the security scanning software will identify that as a vulnerability. It's not just bad, it literally will flag it as a problem. And this is just a matter of the TLS being configured in a way that allows the use of very weak ciphers or key sizes that are too small or things of that nature. There's some other aspects of TLS that are also important to keep an eye on. So this, what I've got here is, it's called Invocation Mechanisms. And in the early uses of SSL and TLS, some of the network protocols would have one port, like port 80 for HTTP, and then they would assign port 443 for HTTPS. Well, the IETF quickly figured out that they were going to run out of port numbers if they had to double up on everything, so you have a non-secure and a secure version of it. And the mechanisms were changed to essentially, once you start a connection, then you could basically issue a command like start TLS that would flip the communications into a TLS dialog. It's important to make sure that when protocols that support this mechanism, that it can be used. And one of the classics is the Lightweight Directory Access Protocol, Ldap. Some implementations require you to connect to a specific port, which early on was sort of assigned to a port number for the secure version of it, but it turns out that was the transition point for the IETF, and it's not really actually been assigned to secure Ldap. Whereas the actual preferred mechanism is you make an Ldap connection and then you do the start TLS. And so this is an area where if you're seeing the use of or forcing the use of separate dedicated ports for the security, it may be a sign that you're not keeping up with the times, so to speak. All right, so here's a target rich. I have even more to sort of go through here. So there's a plethora of poor options that you can use. And I have Wi-Fi up here because most people have at some point been exposed to, there are certain things that you can do here that are bad. Well, for example, using WEP or WPA for the authentication is pretty much guaranteed. You think you've got security on your Wi-Fi connection, but in reality, the bad guys have basically got you. And sort of in combination with those, you can actually use the TKIP encryption, which again, you think you've got a secure communication, but you might as well not have even bothered because it's so weak that your average high school student can essentially get at your data. So these are examples of problems that exist. They're options that are still available, and you as a user may be selecting those options, or there may be a configuration that should have been disabled and it's enabled, and for whatever reason is connecting. This is an example of where you can get into trouble. And it's not that Wi-Fi is inherently insecure, it's that the options and the configurations can definitely expose you if you're not paying attention to it. There's some others in here, for example, SNMP, and you see that they're flagging versions prior to version 3. This is a pretty significant issue if you're relying on SNMP for certain kinds of system management. Version 3 is where basically the security got added. It includes AES encryption, very specific authentication and access control mechanisms. And this is particularly important if you're using SNMP to modify the configuration of a system. If you're simply monitoring it, then you may be able to get away with the previous versions like SNMP version 1.2. But if you're making changes, then this is a situation where you absolutely want to be using version 3. It is not a trivial change to go to version 3. And so many organizations are still relying on older technology. But like I said, you got to be really careful about whether you're modifying systems or not. SSH is another protocol that get used quite a bit. There are definite problems with version 1. You want to stay away from it. Even with version 2, you can run into an assortment of problems that have to do with SSH keys. If you have too few of them, or you're sharing them, or they're static, or worse, embedded, you don't even know that they're going on. So there's a whole set of issues that you can get into. And of course, SSH is a tool a lot of administrators are using to go into systems with root or administrator access. So it's usually the route for privileged users. Things like DNS and NTP, so these are core services. They're often used without any security at all. That's becoming a problem in that they can be used for distributed denial of service attacks. They can, for example, in the case of DNS, there are some specific attacks, cache poisoning, things of that nature. Even with time, there are attacks to try and cause systems to shift their time because they want to corrupt the for example, your logs, or to maybe perpetrate a replay attack that time is an important aspect of sort of guarding against that. So if you can shift the time on a system, it may let you do that replay attack. There are ways to secure these. Some of them are heavyweight, some are not. One of the easiest ways to do this is you have a split DNS or split time, where your external systems use external resources and your internal systems rely on a different set that attackers basically can't get at. So this is, the protocol might be okay, but how you're using it might be the issue. There are other technologies, for example, Iscsi in the storage space. Iscsi has a very limited amount of security embedded in it. There's a lot of dependency on IPsec, which is not a lightweight mechanism, but you do get the benefit of authentication and more importantly, encryption. But you have to use it carefully because individual clients are okay, but you can kill, for example, a storage system that has many, many simultaneous connections. So this is an area where the security may be worse than not using it, and that's something that you have to sort of factor into it. Another storage protocol, NFS, version 3 in particular, very weak security, very difficult to secure it. Many data centers try to keep it locked down inside of the data center and use sort of perimeter technologies, although that's a bit of a fallacy these days. And so you're kind of running at risk if you're using that older version. But again, many organizations have not updated. Another one is SMB version 1. This is definitely under a black swan event. It has essentially been banned by most enterprises. And the reason for that, it was the source of a pretty nasty ransomware attack that happened a couple of years ago. And as a result, it was already kind of on the edge. That pretty much put a nail in the coffin. So if you've got a product that includes it, or you're using it in your enterprise, I can tell you your security guys will light that up and give you no end of grief. One more that I'd like to sort of point out is Syslog, which is a handy protocol for capturing log details. And unfortunately, you can actually have an awful lot of sensitive information show up in Syslogs. And give you an example, somebody accidentally types their password as the username, and you might actually capture that in the Syslog, and simply going through the log might reveal that. So a lot of organizations are actually trying to secure Syslog, and to do that, there's a version of it that can be run over TLS, and then you get integrity and encryption protections. So that's a situation where you've got choices, and then if you're being careful about the technology that you're using, you might use the choice that has the secure option. So those are some examples of poor security option. Some of it is you've got choices from a protocol perspective. Use the newer one, the one with more security features. In cases, it's just a matter of the secure use, how you've configured it, and things of that nature. So with that sort of whirlwind tour of security, I'm guessing there may be some additional questions, and of course we'll try and deal with some of those and follow up in the blog. But I think at this point I will return it back to.
Thank you so much, Eric. This is quite a bit for us to deal with. So please feel free to ask any questions. We'll answer them towards the end or in the middle if we have the time. Now I'd like to present John Kim to you to talk to you about networking issues and protocols that might want to look at.
Thank you very much, Tom. This is John Kim, and let me talk about some not quite retired networking protocols, including versions that maybe should be retired and possible replacements. So the protocols I'm going to talk about are used related to storage. None of them are directly storage protocols, which Alex will cover, but many of them are in fact used to support storage systems or storage protocols. So I'll talk about RoCE, I'll talk about time synchronization protocols, NTP and PTP, then the basic web browsing protocol, HTTP, then DNS, domain name service, and then Vlan versus Vxlan. Let me go ahead and get started. And again, as mentioned, please submit your questions with the online question feature in BrightTalk, and we will answer them online or get them answered afterward in a blog. So first, let's talk about RoCE. What is RoCE? For those of you not familiar, this is RDMA over converged Ethernet. It's a way to get faster, more efficient network transmission of data over Ethernet by offloading much of the networking and reducing the number of copies and offloading that networking work to usually a network card. So there are many network cards to support RoCE, and there are also multiple protocols for RDMA, but RoCE is the most, and they're available on different transports or different types of networks. But RoCE is the most popular one to date so far in Ethernet. So RoCE v1 was the original one, and this ran the InfiniBand transport layer over IP. So it gave good performance and it reduced the CPU utilization, but it was not routable. You had to run it only in one layer 3 subnet. So that really put a crimp on scalability and flexibility, because effectively you could run it in one small network, but for large complex networks that might mean you could only use it within one rack. So RoCE v2, which I believe came along around 2014, made a change, and it runs RoCE on top of UDP, which is a layer 4 protocol, and that runs on top of IP. So since it's using UDP on top of IP, it is routable and it can work with overlay networks. And so you can now run it across more than one rack or more than one network subnet. So today, the default usage of RoCE is almost always RoCE v2. Pretty much all the network vendors that support RoCE support RoCE v2, and only a few support RoCE v1. RoCE v1 is effectively obsolete, but it's still used in a few cases when it's just run on rack scale or a small network where everything is one subnet. Let's go on now. All right, now let's talk about time synchronization. So these NTP, Network Time Protocol, and PTP, Precision Time Protocol, are both ways for servers to synchronize their time, or servers and other devices, across a network. This helps them both get the correct time based on an atomic clock somewhere, as well as have the same time. So sometimes it's more important for all the servers to have exactly the same time than it is for them to have exactly the correct time. And by having the same time, that enhances distributed applications. It can enhance security, logging, online trading, and so forth, where you need to know exactly what order transactions happened or in what order things happened, which happened first, which happened second, and so forth. So Network Time Protocol was the original. It's been around for a long time. The first version first put out in 1985, and it's accurate today to somewhere between 1 millisecond and tens of milliseconds, depending on the version and how it's implemented. And it's based on software timestamps. So when a time synchronization packet comes in, the software in that server or device figures out what time it arrived, and they send a packet back, and they check the delay to transmit both ways, and then they figure out the network delay and then use that to synchronize the time. But because it's based on software, that limits the precision. So you can see here the different versions that came out, with the latest version reaching requests for comment, or RFC, in 2010. Okay, Precision Time Protocol started out in 2002, and this is a more precise version. And it largely relies on hardware timestamps, where hardware in a special card in the server or in the network card or in the switch is able to stamp the packets as they go through, and thus there's less variability and a higher degree of precision in determining the network propagation delay between nodes, and therefore in determining the actual time difference and the accurate time. So it can achieve accuracies as good as 1 microsecond between different nodes, and in fact the accuracy level is measured in nanoseconds, or the variability and the jitter of the timestamps is measured in nanoseconds. So the answer is both of these are popular. Neither one is itself obsolete, but PTP is now taken over whenever very high precision is required. And specifically within the two versions, NTP versions 0, 1, and 2 are effectively obsolete. So people are using version 3 and version 4, but as Eric noted, version 3 does have some potential security vulnerabilities which are addressed with version 4. In the PTP side, version 1 is effectively obsolete. It was officially called IEEE 1588-2002, not version 1. But what happened is the second and third version, which came out in 2008 and 2019 are compatible with each other, but not compatible with the first version from 2002. So that's effectively obsoleted the first version of PTP. Now, HTTP, so Hypertext Transfer Protocol, very popular on the web. So it's usually not used directly for for block and file storage, but it may be used for object storage transmission, and it's also used for remote or web-based management or access or configuration of storage devices. So the default application of this is to run unsecured on port 80 over TCP, but these connections can be hacked or intercepted fairly easily. So someone could use it to intercept the data or to redirect your browser to a malicious website by pretending to be the website you want to go to, or by intercepting your traffic. And so therefore, it's now considered better to run most web traffic and websites over HTTPS, which uses SSL or TLS to encrypt the traffic. As Eric pointed out, SSL itself is obsolete, so if you want to do this correctly, HTTPS should run over TLS. So this is no longer for just e-commerce, but again for different types of traffic, including object storage traffic, management, and a lot of transactions and communication. Even some types of telemetry or management may happen over HTTP, and preferably now HTTPS. And you can tell the difference in your browser if you see the HTTPS and the little locked symbol. If you're still running HTTP, you have an open lock. So one important aspect of this, and the reason is that websites which still run HTTP and without the security get lower rankings in major search engines. So your search results improve if your websites are running HTTPS. All right. So DNS versus DNS over HTTP, or DOE. So domain name service is how servers translate from a website or a domain name, such as Microsoft.com or SNIA.org, to a specific IP address. So it's a directory that tells you how to find the servers or websites that you want. So regular DNS just runs in the clear, and the risk is that people could figure out what servers you're going to, and therefore figure out, sort of track your activity or your intentions or what your interests are by seeing all the different web servers that you're visiting. Or they can see if you're going to YouTube or Minecraft or Reddit or and so forth. So there's the ability to encrypt DNS over HTTPS, and this would improve privacy and reduce tracking. But it doesn't encrypt everything because it only encrypts the DNS requests. So people, it prevents someone from intercepting your DNS lookup. But then after you connect to the web server or other internet site, your subsequent traffic is not necessarily encrypted, or it's not encrypted by DOH. You'd have to encrypt it or protect it with some other tool, like HTTPS, for example, for regular web traffic. Otherwise, the subsequent traffic can still be intercepted, and someone could still figure out where you're going and what your interests are by doing that. The other problem is that DOH disables some security controls. So a company might use their own DNS servers and block malicious websites, or track activity to see if people are going to the wrong websites. When you use DOH, now those trackers become disabled, and because the browsers are being directed to a DOH-enabled domain name server, usually outside the ISP or outside the regular company's internal DNS servers. So regular DNS is still far more popular. DOH is fairly new. Most of the newest version of most browsers have started supporting it, but a lot of ISPs or networks don't support it. So again, to use it, you have to point your browser at a special DNS server. There are some other options to do security for DNS, including DNS over TLS, and then oblivious DNS over HTTPS, which uses a proxy in between. So in this case, DNS is not ready to retire, but there are some issues, and there are some proposals or new technologies that are alternatives to regular DNS. And finally, we have Vlan versus Vxlan. And again, this is not directly a storage protocol, but in the world of cloud, virtual machines, and containers, it's quite a good chance that any storage traffic from those VMs or containers may be running over Vlan or Vxlan. So Vlan lets you subdivide a network into up to 4,000 virtual networks where each one acts like a different network, even though they're running on the physical network. And this limits broadcast traffic. So if I have a group A and there's a broadcast traffic, it's only going to all the nodes or servers that are in group A, and it won't bother the servers in groups B, C, or D. And so this simplifies traffic management. It also improves security because a VLAN can be set up so that servers in group A cannot see anything in group B, and those in A and B cannot see what's in group C, or VLAN C. But the scalability limitation means that as we get to the world of cloud, especially large cloud and lots of virtual machines, alternatives are needed. So their most popular is Vxlan, which is a virtual extensible LAN, and then others are NVGRE and Geneve, and there are even a few more beyond that. But the most popular today is Vxlan. So these support a more sophisticated and flexible type of virtual network with tunneling and up to 16 million segments. So that's enough for most cloud, even most hyperscalers, that each section of the network could be subdivided. They could create up to 16 million virtual LANs. And it lets a layer 2 domain span, which runs at like the Ethernet level, to span layer 3 domains. So I could have different IP subnets, but I could create a virtual layer 2 network that runs across those different subnets, as well as be able to simplify migration of virtual machines or containers across the physical network with keeping their same layer 2 address, even though I move them around to different parts of the layer 3 network. So it's ideal for managing lots of virtual machines and containers. Ripe for refresh. The verdict is VLAN is still in use. It doesn't need to be replaced everywhere, but in the large cloud or sophisticated container-focused implementations, VLAN is being retired and replaced with more scalable solutions, as listed here. So that's the end of my section. And again, if there are any questions, we'll get to those later. Let me hand it back to Tom.
Okay. Alex McDonald will be presenting to us on NAS protocols, but let me warn you, there are some international phone line connection problems. So if the audio quality gets to be too bad with Alex, we will be able to continue his call. So Alex, please proceed.
Thanks, Tom. I'll speak really slowly and clearly and attempt not to stumble on my words. How does that sound? Is that okay?
No better.
No, good, good. So, NAS protocols. I get the fun bit. I get the bit right at the back end. By the way, we haven't had any questions, but we have had one piece of feedback from the audience, which is terrific. So feedback before we finished, but no questions. Ah, well, let's see if we get any during this section. The ones I'm going to talk about are the NAS protocols, SMB and NFS. These are file system protocols, and they are of historical significance as well as of real everyday modern application. So this is something this is technology that's been with us for a long time, since the 1960s, where the earliest references to file systems was made. And that's a long time in IT. If you think about it, that's what, 60 years ago? So some of these technologies that we're talking about first saw the light of day 60 years ago. That's seriously impressive. NFS was from Sun in the mid-1980s. And we've only really seen two major versions of NFS. There was NFS version 2, but that fairly quickly got subsumed by NFS version 3. And NFS version 3 lasted for a long, long, long time until NFS version 4 came out. That doesn't mean to say NFS version 3 died, and I'll talk a little more in detail about that. But NFS version 3 was the predominant file system protocol, particularly in the Unix world, for a long, long time. And it's proved its worth over the years. FMB was originally from IBM. It was part of LAN Manager, in fact, and that saw life in the mid-1990s. So it's a bit younger than NFS, and it was originally called CIFS, which I still see references to CIFS out there. Please stop it, whoever you are. It's not been CIFS for a long, long, long time, and CIFS only really refers to SMB version 1. But SMB also has a long, long history. So the question I always ask people is, why should you change? What is it that is forcing change here? If these protocols have been around for such a long time, then presumably we ironed out a lot of the wrinkles a long time ago. Not really. There were a number of things that we didn't really realize a number of years ago. The first was the ubiquity of the internet, and which allowed access from computer to computer in a way that we'd never seen prior to its introduction. And the second, I suspect, was security, which we always did things as also security. And I know Eric has scared a lot of you now. He's actually put a fear of God into a lot of people over the years talking about security or insecurity. But there is some good news. We're getting much better at handling security issues. And with a little forethought, with a little care, you can actually build very secure and very robust intranet working and internet working file systems. So secure. Stuff that's over 30 years old probably, no, definitely has vulnerabilities. And they're not always as just there in case anyone wants to argue the peace. No, come on, it does. We're going to see that very shortly. There are some good news out of all this, though. In the move through the years, we've improved several things. First of all, performance. Modern protocol stacks are a lot more efficient and provide much better and lower latency, much higher bandwidth than old technology stacks. One other thing you need to realize as well is in terms of the data that we're shifting down pipes these days, low latency is something that is getting increasingly important. And a software stack that's too deep and takes too long to deal with I/O requests isn't that particularly useful. I mean, when we were dealing with slow disks with milliseconds of latency, then having a software stack that added half a millisecond was neither here nor there. But having software stacks nowadays that add any latency in that sort of order, when we're looking at storage that can provide, in the hundreds of nanoseconds latency, that's a serious issue. So some of these stacks are a lot lighter, a lot thinner and cleaner than they used to be, so the performance is better. The other thing is scalability. The amount of parallelism that can take place in a modern file system is immense, or the demand on it is immense. And newer file system protocols can scale much better than their predecessors could. And we've also got lots of features to support modern thinking, modern ways of dealing with the technology. So we can do things like, support databases much more easily over the internet, not just within, a single machine supporting a database where we're going direct. We can actually provide these databases over file protocols. And things like space efficiency, we're always interested in making sure that we reduce the amount of space used. So the pressure for change is definitely there, and it's not just security. There are a change and differences in the ways that we employ and develop and deliver applications that demand much later protocols. The problem is some of our traditional applications will still be running on pretty traditional file protocol stuff. And that attitude, I think, needs to change. It is changing, but needs to change more quickly, I believe. So, when we come to SMB, Eric's already been into this. In fact, the ransomware was WannaCry and Petya, which did a fabulous job of demonstrating how modern cryptography works. In fact, the big cryptographic users these days are people delivering and developing ransomware. And the compression that they used, the encryption that they used on the data, and then you had to go and buy a key off them, still do them. There's still this stuff going on. But SMB1 has been very regularly exploited for ransomware, and you really need to get rid of it. It's no longer installed by default. It is a pretty old protocol, and it hasn't been installed for some time. There's actually a link here. So this is a fairly high-level overview. So I'd go look at the link, which talks about SMB1. And, really, if you've got stuff using SMB1, stop it. Just say no. You can't. You really ought not to be supporting it. SMB2 and 3. So SMB2 was in 2006. and SMB3 in 2012, and the current version's 3.1.1. I'd still strongly recommend not using SMB2. Now, SMB2, when did it arrive? It arrived with Windows Server 2008, Windows Vista, Windows 7. These SMB versions you should really have got rid of by now. I mean, this is pretty old technology. We're talking stuff that's greater than 10 years old, and you should be thinking about SMB3. A lot of features in SMB3 that are incredibly attractive, and I'm just going to run through a few of them very quickly. Transparent failover. I mean, that's a real plus, the ability to suffer disruption to network communications and yet still maintain a connection to a database or connection to files, file shares at the back end is a really terrific thing, and it makes administration and providing storage services that much cleaner and easier. Scale out, much bigger scaling, encryption, a high level of encryption with SMB version 3. It's much better than previous versions. So there's a whole bunch of positives in moving to later versions. Old versions are risky. New versions are much less risky, and obviously maintained. The older versions aren't. They haven't been for some time. So that's some of the features. You also got the ability to be backward compatible, but again, if you've got SMB version 2 clients, I'd suggest that you need to look at the applications and modernize those as well. Lastly, you'll find an SMB3 presentation which covers a lot of these points. So that link down at the bottom is a pointer to our educational library. And there, if you type in SMB3, you'll actually get a whole bunch of presentations on SMB3 that will help you to make that migration and help you to see what advantages and kind of technology that SMB3 supports. So that's our SNIA.org/educational. Go and take a look at that. It's a huge resource. Lots of other stuff in there as well, beyond just SMB. So that's SMB. Say no to SMB1. Say no thanks to SMB2, and positive look to supporting SMB3 and some of the features that it has. NFS. This is one of my, I like NFS. NFS is a really nice, simple protocol. Uses remote procedure calls, which makes it easy to write applications that can talk over the network as well as talk to local disk. There are major differences between version 3 and version 4, and nobody says it's easy to move from 3 to 4. I've talked to a number of people over the last 5 years or so about their migration from V3 to 4, and it's sometimes difficult. It's not particularly smooth. The protocols work in different ways. V3 comes with an awful lot of baggage. V4 has a lot less. The reduction in baggage also means there's a change in the way that the thing performs and the way that you need to set up a version 4 environment is much different from V3. And in particular, there are some serious advantages to V4, but they do involve some work. The first one is security. That's always a winner. Eric covered some of the security issues with V3. And it's more than just security, though. There are also a large number of supporting casts required for version 3. So you've got things like, mount and auto mounters and a variety of ports required that make securing a V3 environment pretty difficult. You're punching lots and lots of holes through firewalls, and that's never a great thing to be doing. V4 boils down to one port address through the firewall, which makes things much, much easier. And also it has modern network relevance V4, so it does things that make it easier to operate efficiently and effectively over WAN. For instance, compound RPC operations, where we can compound up a whole bunch of I/O operations like open, read, close into a single operation. And so we can actually retrieve data without actually having to issue an open, wait for a response, a read, wait for a response, a close, wait for a response. We don't need to do that. We can actually just issue one operation, we close and get a response that tells us, here's the data, or here's the problem I had issuing, following one of those commands. Internationalization. Hey, there's more to life than ASCII. So support for UTF-8 with NFS version 4. And a couple of other really cool features that I quite like. For instance, a pseudo file system that allows you to build a directory structure that's different from the directory structure that is actually on disk. You can actually build pseudo file systems over the top of the real file system and make it look like the file system's constructed differently. And that's a really cool feature because it allows you to manage much more easily in terms of what you present to users as a file structure, as opposed to how you actually store the stuff on disk itself. You can have a completely different file structure with a pseudo file system, different hierarchical views. And also things like, advanced techniques like thin provisioning. That's where you actually only provision what you're using. And you wait, so the large requests for space aren't honored immediately. They're honored over a period of time as you write the data. Hole punching, which takes the holes and removes the holes and squeezes the holes out. And both these techniques save quite a lot of space. And there's a little diagram there showing you thin provisioning. The stuff at the top hasn't been written to yet, so don't provision it. And then when there are holes, squeeze them out. And that actually reduces the amount of data that we need to store on disk. And can improve other areas as well, like performance, because you obviously got less data that you're having to transfer around. So there is a paper and a presentation on NFS v4. The paper, an overview of NFS v4 is out there in direct link, but you can also find it in the educational library. And also a really good presentation, though I say it myself because I wrote both the paper and the presentation, about NFS version 4.2 and some of the features that it brings in a modern NFS environment. So I recommend you go and look at both of those. Again, the educational resources on SNIA.org are wonderful, and typing in NFS v4 will get you a whole bunch of stuff about that really fine protocol. So I'm going to pass it back to Tom. That was just a quick overview, remember, a high level. Please go and look at those links for more information. Tom.
So, ripe for refresh. I love that picture. It tells the story. So, Eric covered for us the issues around different cryptography settings, why we need to replace any version of SSL and the earlier versions of TLS. John talked to us about SSH, SNMP. Eric again, still talking about that and Wi-Fi usage, how Wi-Fi can be secure or not. HTTP, everyone should be using the secure version of the hypertext transfer protocol. There's no reason not to. And you should be using TLS at least 1.2 in that case. We've been given many reasons why we need to consider using or throwing away SMB1 and probably even SMB2. Now, there are some more difficult transitions to make, and you'll want to work with your suppliers. If you're going from Rocky v1 to Rocky v2, and most definitely if you're going from NFS v3 to NFS v4. These are complex tasks not to be undertaken lightly. And so these are the kinds of things you want to be looking at in depth. So among questions, Eric, one I know I have is I use SSH to manage a lot of my servers within my own company. And how can I tell what version of SSH I'm using?
Well, that's an excellent question. Depending on the implementation, you may be able to actually, it may actually tell you when you're looking at the tool. But in general, you may actually have to go to the essentially the source of the tool to make sure you've got the right version. Now, from a security perspective, if your security team is chatting with you, they'll be able to tell what version of SSH is enabled. And that's not necessarily the version you're using, because you could actually have a tool that supports both versions. But you may have the choice, and you may be making the right choice as to which one you're using. Some of the other issues that I raised with SSH keys, and I know of at least one instance I came across years ago where a worldwide use of SSH relied on a single key for everything everywhere, and that's the kind of thing that security scanning wouldn't necessarily turn up. And so you've got to, that's something you have to actually be careful about how you've implemented and deployed it. So version, probably the easy thing to sort of chase down, either by checking the software itself or by checking your security scans. Some of these other issues, configuration issues, are much harder to chase down.
Okay, thank you. One question we have from the audience is, can we use a robust logging system and real-time analysis plus real-time configuration in the transport layer? Have any takers on this?
The transport layer. So you mean, for example, using Syslog and streaming that into some sort of analytical, like SIEM, for example?
I believe that's what they're asking for.
Okay. I mean, the general recommendation from practitioners at the centralized, like SOG-based mechanism where you're getting event log data off of your infrastructure that hopefully is all time synchronized. This is where NTP comes into play, or something equivalent to it. And that comes down to a location that then can be continuously monitored. So the days of post-processing log files looking for bad things is long gone in most environments. They literally want to be able to monitor on a continuous basis what's going on in the infrastructure, because in some cases, zero-day events, so an attack, a new attack that's not been seen before, may have some sort of anomalous artifacts that can clue you into, that an attack is underway. And if you're continuously monitoring, you might see those and flag. And to give you a simple example is you've got users in Singapore that work Monday through Friday, 8 to 5, and somebody's doing something crazy on a Saturday. If you're doing continuous monitoring, something like that is easily flagged. And it doesn't even matter what they're doing. It's just the fact that it's an odd sort of time usage is a clue to the security personnel that there's something weird going on here. So real-time analytics is absolutely being used. And in fact, what we're seeing is increased use of artificial intelligence as well to help out on the security side.
Okay. And a comment we got from the audience, which I completely understand, is reminding us that the access control lists and file permissions are something we need to watch as well. If you give someone a 777, or if you give mark your files as all sevens, there is no security, right? So you only want to do that in a very limited cases. And the same thing for the Windows world, where everyone, where you would mark it as everyone.
Yeah, so I'd like to sort of piggyback on that. Yeah, when you've got multi-protocol scenarios, In other words, you're coming at the data from both NFS and maybe SMB. This is one of the tricky parts of making sure that your access controls line up so that you don't have, you don't inadvertently expose it, because there's not a 100% alignment between the two on access controls. So this is one of the concerns with security personnel, is when you're giving data availability through two different views of the world, you might have exposed more of it than you thought you were. Sorry, Alex.
Yeah, no. So I was just going to jump in and say, good security with a protocol is one thing, and you can secure a protocol as well as you like. And if you decide to let people have access, that's your problem. The protocol, what we're trying to do with these protocols is actually stop inadvertent or illegal access. We're not trying to stop authorized access. So there's a whole different process there in terms of making sure that people have the right level of access to the data that they're going for. All I was trying to point out in my section, I think you and yours as well, the security is not as good on some of these older protocols, so you need to upgrade them so that you don't get the wrong people getting access that you didn't mean to. But if you mean to have them access, or you let them have access, they will have access. The protocol is not going to help you. That's a completely different administrative problem.
Okay, we're reaching the top of the hour. Thank you all very much for coming. We'd like your feedback on this webcast. Was this useful to you? Please let us know so that we can improve our educational materials as we go forward. We will have the slides available, not only here today when you from this site, but you can also go into our educational library and find them there. We will be putting up any additional questions that come in from over our blog posts, and please feel free to follow us on Twitter as well. Thank you so much for everyone who participated in this today, particularly my other speakers here. John, Eric, and Alex, thank you again for being a part of this webcast. And thank you all for attending.